So check out this problem. Construct a 3 to 1 convolutional encoder whose gender sequences are given by G1 of 1 is equal to 1 1, G1 of 2 is equal to 1 0, G1 of 3 is equal to 1 0, G2 of 1 is equal to 0 1, G2 of 2 is equal to 1 1, G2 of 3 is equal to 0 0, and find the output when the information sequences is 1 1 0 1 1 0. Alright, so let's do this problem. So here the first thing you need to understand is, first we will draw the encoder, right? First we will draw the encoder. So this is a 3 to 1 convolutional encoder. So what is the meaning of 3 to 1? That is the number of output is equal to 3, the number of input is equal to 2, and the value of m is equal to 1. So there are 3 outputs, 1, 2, 3. There are 3 outputs. So this is a 3:1 mux, right? Let me draw like this. Okay, this is it, and this is V of 1, this is V of 2, and this is V of 3. V of 1, V of 2, V of 3. Okay, and also there are the number of output is equal to 2. So let me draw that. Number of output is equal to 2, 1 over here and 2 over here. Okay, this is U of 1 and this is U of 2. Okay, U of 1 and U of 2. Okay, so now 3 to 1, the value of m is equal to 1. The value of m is equal to 1 means only one shift register block, but there are 2 inputs. So since there are 2 inputs, each input will have only one shift register blocks. So this is 1 and this is 2. Okay, that is the meaning of 3 to 1. That is, every single input they will be having only one shift register block. So since there are 2 inputs, each input will have its own shift, will have its own one shift register block. Okay, so let's look at the connection. So to draw the connection, simply look at the value of the generator sequences. All right. So here, if you can see over here, the value over here is G11. I forgot to draw the XOR function. Let's draw the XOR function over here. Okay, XOR function for here, V of 1 is from G1 of 1, it is 1 1. That is from here 1 1, which means there's connection from here and there's connection from here. Let me draw that. You can draw it any way you like. All right, whichever way is comfortable for you. There, okay, 1 1. And what about in terms of the second input? That is represented by this G2 of 1 means the connection from the second input to the first output. This connection from the second input to the first output. Second input over that is from here to the second output. So sorry, to the first output. So here is 0 1. 0 1 means there is no connection from here, but there is connection from here. So I'm going to draw that like so. Okay, so this is the meaning of this. This is 1 1 1 1 and this is 0 1 0 1. No connection and there is a connection. Okay, likewise this is in terms of the first output, right? See, in terms of first output, the small bracket, in terms of first output. Now let's look at the second output. The second output is G1 of 2 and G2 of 2. This is with respect to the first input, this is with respect to the second input. All right, so in order to connect V of 2, first I will connect in terms of the first input to the second output, which is 1 0. 1 0 means there is connection from here, but there is no connection from here. So if there is a connection from here, I need to take it and connect it over here, which means I need an XOR function. I'll take an XOR function, I'll put it over here, and in order to do that, all I have to do is only from here, right? 1 0, only from here. So which means I will connect like this. Okay, it saves a lot of time. There you go, like this. Okay, this connection over here. There is no connection from here because here it is 0. So there is no connection over here. There's connection only from here. That's why I drew from here. You don't have to draw exactly from here. You can take from the same line. The same is this exact line. This whole thing is single connection. Okay, so that's it. That's 1 0. What about with respect to second input? To connect the second output with respect to the second input, the value is 1 1. Value 1 1 means there's connection from here and there is connection from here. Connection from here, you can take it from here, right? From the second, this one you need to draw it. So I will draw it and I will connect it like so. And this is it. This is called as 1 1. This 1 1. G2 of 2 is equal to 1 1. That is with respect to second input to the second output. 1 1. Okay. So that is it. Now let's look at the v of 3, or the value of v of 3. Okay, there's a reason why I'm not drawing any XOR function over here, because if you look over here, the value of g of 3 is only has 1 over here. The rest of the picture there is no 0. The rest of the picture there is no connection, because all of them are 0. So you see, with respect to the first input, there is a connection 1 0 1 0, means there's only a connection from here, this connection. That's it. 1 0 from here. Okay, 1 0, and there's no connection from here because there's 0 over here, so there is no connection from here. And if you look at the with respect to the second input, you can see that there is no connection from both the sides. That is either from here nor from here, right? Neither from here nor from here. Both of them there is no connection to the v of that. So it's only a single connection. So if there's only a single connection, there is no need to draw the XOR function. Okay, XOR function is used only if you need to add more than 2 numbers, 2 and more than 2 numbers. See, here only one single connection is there, so there is no need of any XOR function over here, right? So this is the circuit diagram of a 3-to-1 convolution encoder. Now what I'm going to do is I'm going to apply transform domain approach in order to find my output, or I'm going to apply convolution encoding using the transform domain approach, and this time I can only do that using the transfer function g of x. I can only do that. So first thing what you need to do is you need to express each of these sequences in terms of the polynomial. That is what you need to do. Okay, so here what you're going to do is over here is that here you can see that the value of g1 of 1 of x, okay, is equal to 1 1, which means 1 plus x. Okay, 1 plus x, 1 plus x over here. G2 of 1, okay, G2 of 1 of x is equal to x. That's it. What about g1 of 2? G1 of 2 of x is equal to 1, only 1, nothing else. Okay, what about g2 of 2? G2 of 2 of x is equal to 1 plus x. Okay, what about g1 of 3? G1 of 3, right, like over here, g1 of 3 of x is equal to 1. Okay, and what about g2 of 3? G2 of 3 is equal of x is equal to, both of them is 0. That means it is 0 plus 0 into x, which is 0. Everything is 0. So just write 0 over here. So this is the polynomial version of these generator sequences. Okay, see, it is 1 plus x. Here it is 1 1, right? So that's why it is 1 plus x. Here there is 1 plus x, but here 0 into 1 is 0 and 1 into x is x. That's why only x is over here. Here this is 1 into x raised to 0 is 1, 0 into x is 0. That's why only 1 over here. And g1 of 3, that is also 1, and g2 of 3, that is also 0, because both of them are zeros, right? It means it is 0 plus 0 into x, which is 0 itself. Okay, so now what I'm going to do is I'm going to express my system transfer function in terms of the g of x. So here this is actually a k by n, 2 rows and 3 columns, right? That is what this means. So what are those 2 rows? That is the rows representing g1 and g2, and what are the columns represents g of 1, g of 2 and g of 3, right? So which means this is how you write it: g1 of 1 of x. Here you write g2 of 1 of x. Sorry, g1 of 2 of x. Don't get confused, okay? And here you write g1 of 3 of x. Here you write g2 of 1 of x. Here you write g2 of 2 of x. And here you will write g2 of 3 of x. Okay? Or in other words, g of x is equal to what is g1 of x? G1 of 1 of x is equal to 1 plus x. What is g1 of 2 of x? That is 1. What is g1 of 3 of x? That is also 1. What is g2 of 1 of x? That is x. What is g2 of 2 of x? That is 1 plus x. And what is g2 of 3 of x? That is 0. This is it. See, so this is how we represent the system transfer function. Okay, here in this example, this is actually a system transfer function of 3-to-1 convolutional encoder, right? 3-to-1 convolutional encoder, right? That is 2 rows and 3 columns. So now you're going to express, now what you're going to do is you're going to find the value of u of x. But u of x, you cannot simply write the equation for u of x because there are 2 inputs. See, the number of inputs is equal to 2, which means there is a u of 1 of x and there is a u of 2 of x. Okay? So in other words, first you need to find the value of u of 1 and then you need to find the value of u of 2. Then only you can write the value of u of x. So how to find the value of u of 1 and u of 2? Since this is a 3-to-1, which means there are 2 inputs, which means you see you need to mark them. You need to mark them. This is the value of 2 inputs. See, 1 1, that's the first input. 0 1 is the second input. 1 0 is the second input. Why did I mark them in groups of 2? Because here there are 2 inputs. The first input you will be applying is 1 1. The second input you will be applying is 0 1. The third input you will be applying is 1 0. You see, that's how you are going to apply the inputs. That's why this is called as a 3-to-1, because you will be applying 2 bits at a time. And those 2 bits are the first 2 bits, the second 2 bits, and the third 2 bits. Or in other words, your u of 1 is this, this, and this. That is your u of 1. And your u of 2 is this, this, and this. Okay? Because, reason is because, like I said, you will be applying 1 1, then you will apply 0 1, then you will apply 1 0. That's how you're going to apply. You're going to apply, first you're going to apply 1 1. So which means this is u of 1, this is u of 2. Then you're going to apply 0 1, which means this is u of 1, this is u of 2. Then again you're going to apply 1 0, which means this is u of 1, this is u of 2. So in other words, your u of 1 is 1 0 1. This is your u of 1, 1 comma 0 comma 1. This is your u of 1. And your u of 2 is 1 1 0. 1 1 0, 1 comma 1 comma 0. This is your u of 2. Okay? Or in other words, u of 1 of x is equal to 1 plus x square. 1 plus 0 into x plus x square. And u of 2 of x is equal to 1 plus x. Okay? 1 plus x plus 0 into x square. 0 into x square is 0. So u of 1 is 1 plus x square and u of 2 of x is 1 plus x. Okay, so this is how we write it. So now we are going to find the value of v of x. So v of x is equal to u of x into g of x. This is g of x. Okay, and what is u of x? U of x is nothing but u of 1 of x comma u of 2 of x. U of 1 of x comma u of 2 of x. Okay, that is u of x. Or in other words, u of x is nothing but, what is u1 of x? 1 plus x square, comma, what is u2 of x? U of 2 of x, 1 plus x. 1 plus x. Or in other words, v of x is equal to 1 plus x square and 1 plus x, and g of x is this whole thing, that is 1 plus x, x, 1, 1 plus x, 1, 0. Okay, so you see, this is called as v of x. Okay, you need to understand that this is not your output. This is not the polynomial of this. Okay, this is small letter v. If you want to find the value of small letter v of x, what is this v of x? Capital letter v of x. Capital letter v of x means this one. That is nothing but a collection of the output. V of 1 of x, comma, v of 2 of x, comma v of 3 of x. Okay, this is the output that you're going to get from here. By doing this calculation, you will find the value of v1 of x, you will find the value of v2 of x, and then you will find the value of v3 of x. That is the meaning of this v of x. But this is not your output. Your output is actually small letter v, or small letter v of x. The polynomial form is small letter v of x. And what is the equation for the small letter v of x? The equation for small letter v of x is, since there are three outputs, it will be represented as v of 1 of x cube plus x into v of 2 of x cube plus x square into v of 3 of x cube. This is how we represent the total output combination. Okay, why x cube? Because this is a multiplexer of 3:1 multiplexer, right? Or you are using a 3:1 switch, which means that now v of 1 is being selected after every 3 cycles, right? 1, 2, 3, then comes the next cycle over here. That's every third cycle only the v of 1 value comes. Like that, every third cycle only v of 2 value will come to the output. Every third cycle only v of 3 will come to the cycle, right? Because 1, 2, 3, it has to rotate, right? Up from v of 1, v of 2, v of 3, then again v of 1, v of 2, v of 3. So that is why so in order to express that delay only, we are using it in terms of the power will be in terms of x cube. Okay, and then you're going to join them in sequence. So since you're going to join them in sequence, first you write the value of v1 of x cube, then in order to write the value of v2 of x cube, along with this you need to multiply it with x, and then in order to write the value of v3 of x, again you need to join them after v2 of x. So here already they're using x, so next it will be x square. That is why the output will be represented like this, v of x. This is your output. Okay, so how to find the value of v1 of x, v2 of x, and v3 of x? From here. And how to find this value? From here. So this is one. You see, look over here. Here this is nothing but 1 into 2 matrix, right? This is 1 into 2 matrix. What about this? This is actually 2 by 3 matrix, right? This is a 2 by 3 matrix. So if you cancel these two values, you will get a 1 by 3. So by multiplying them, you will get a 1 by 3 matrix. That 1 by 3 matrix is this one: v1 of x, v2 of x, and v3 of x. So let's find the value of v1 of x, v2 of x, and v3 of x. Okay, or in other words, v of x is equal to, let's begin. So first value is multiplying this with this, and you will get 1 plus x square into 1 plus x plus 1 plus x into x. Okay, that is the first value, right? The second value is multiplying this with the second column, and you will get 1 plus x square plus, and here you will get 1 plus x into 1 plus x. Okay, that's the second value. And the third value is multiplying this with the third column, and you will get 1 plus x square plus 0, because 1 plus x into 0 is 0. So this is v1 of x, this is v of 1 of x, this is v of 2 of x, and this is v of 3 of x. So let's write it. That is v of x is equal to this is multiplying this with this, it becomes 1 plus x square, right? Or multiply 1 plus x, we'll write 1 plus x, 1 plus x plus this into this is 1 plus x, this into this is x square plus x cube, x square plus x cube plus, and over here you have x plus x square, x plus x square, comma, and what about v of 2 of x? It is 1 plus x square plus 1 plus x square plus this into this is 1 plus x plus this into this is 1x plus x square. So this is v of 2 of x, comma, and what about v of 3 of x? V of 3 of x is 1 plus x square plus 0, which is 1 plus x square. There. Okay, so this is v of 1 of x, this is v of 2 of x, this is v of 3 of x. Now in terms of in v of 1 of x, you can say that you can cancel this x and this x, you can cancel this x square and this x square. So therefore I can say that v of x is equal to, so v of 1 of x is 1 plus x cube, right? 1 plus x cube comma, what about v of 2 of x? V of 2 of x, this one and this one you can cancel, this x square and this x square you can cancel, this x and this x you cancel. So it means every term is cancelled. In v of 2 of x, every term is cancelled, which means v of 2 of x is nothing but 0. Comma, and what about v of 3 of x? There's nothing to cancel, it is 1 plus x square. So that's it. This is v of 1 of x, this is v of 2 of x, this is v of 3 of x. This v of 1 of x is equal to 1 plus x cube. Okay? Or in other words, the sequence v of 1 is equal to 1 comma 0 comma 0 comma 1. Okay? This is the value of v of 1, the corresponding polynomial of the sequence of this polynomial. Now, what are the value of v of 2 of x? V of 2 of x is equal to 0, right? So, which means that v of 2 is equal to 0 comma 0 comma 0 comma 0, right? Why there are 4 values? Why are there 4 bits? The reason there are 4 bits is because, like I said, you need to look at the length of the information sequence. See, this is not the length of the information sequence. This is not your information sequence. This is the value of u combined. That is u of 1 and u of 2 combined. So if you want to know the length of your information sequence, it is this length, the individual length. That is what we discussed in the previous video. The individual length. So here the length of the information sequence is 3. See, the length of the value, or the capital letter L, is equal to 3. So 3. Right? So in that case, the value of L is equal to 3. And what is the value of M? The value of M is equal to 1. Right? 1. So which means the total length of your output sequence will become 3 plus 1, which is equal to 4. That is why the length of your output sequence is equal to 4. Each of the output sequence is equal to 4. Now let's look at the value of v of 3 of x. The v of 3 of x is equal to 1 plus x square, right? 1 plus x square. So therefore v of 3 is equal to 1 comma 0 comma 1 comma 0, right? 1 plus 0 into x plus 1 into x square plus 0 into x cube. So 1 0 1 0. Or in other words, your value of v is equal to 101 comma 0 0 0 0 0 0 comma 0 0 1 0 0 1 comma 1 0 0 1 0 0. This is the value of your output sequence. Okay, if you still need proof, you can express this in terms of v of x. You can express in terms of v of x. So how to write the terms of v of x? To write the terms of v of x, yes, using this equation, right? That is v of x is equal to v of 1 of x cube plus x into v of 2 of x cube plus x square into v of 3 of x cube. So what is v of 1 of x cube? That is the replace, this is 1 plus x cube, right? So v of 1 of x cube is actually 1 plus x raised to 9, right? Because replacing x with x cube, this will become x raised to 3 into 3. X raised to 3 raised to 3, or the power of 3 raised to power of 3, which becomes 9. 3 into 3 is 9, so x raised to 9. So 1 plus x raised to 9. And what about the value of v2 of x cube? Well, already v2 of x is equal to 0. So therefore v2 of x cube is also equal to 0, because there is no x over here, right? So therefore this is also equal to 0. So plus 0 plus, what about this one? This is nothing but x square into, what is v of 3 of x cube? V of 3 of x is 1 plus x square. So v of 3 of x cube is 1 plus x cube raised to 2, or 1 plus x raised to 6. Okay, this is v of 3 of x cube. 1 plus x raised to 6 is v of 3 of x cube. Okay, so your answer is, let me see, 1 plus x raised to 9 plus x square plus x raised to 8. Or in other words, this is 1 plus x square, right? 1 plus x square plus x raised to 8 plus x raised to 9. This is your answer. If you look over here and here, you see the answer is exactly the same. Okay, exactly the same. This is the sequence. This is the sequence, and its polynomial version is written over here. Okay, the polynomial version is written over here, which is 1 Okay, this one represents this x square, this x raised to 8 over here, this is x raised to 9 over here. Okay, and then the remaining rest of the values will become 0. Okay, and totally there will be 12 bits. Okay, totally there will be 12 bits, 4 into 3. Okay, so this is your answer.